For this lesson, you're going to go ahead and need your construction tools. You're going to need your compass and a straight edge. So what we're going to be doing here is we're going to be constructing an isosceles trapezoid. And based off this isosceles trapezoid, we're going to discover the properties of an isosceles trapezoid. So let's go ahead and get started. I want you to take your straight edge, and I would like you to draw a line like I've done here. Then I want you to go ahead and take your pencil, and I would like you to put a dot somewhere above your line. What we're going to be doing is we are going to be constructing a parallel line through a point, because my definition of a trapezoid is it has one set of parallel sides. So through that point that we drew, or that we created on our paper, you're going to go ahead and take your straight edge and draw a line through that point to the line below it. Now you need to take your compass, and we are going to go ahead and move it to the vertex of the first line I drew in the intersecting line. Oops. Okay, and I'm going to extend it out here. And I'm going to draw a curve just like so. So we've already learned how to construct these parallel lines, so this hopefully is a review. I'm not going to change my measurement, and I'm going to take my compass up to the first point that I drew, and I'm going to go ahead and draw another curve. Now what I want to do is I want to measure the distance below of the intersecting arc. So I'm going to put my circle drawer at this point, and I'm going to move my other one around. Oops. So that I can go ahead and find the distance right here. So all I'm doing is measuring that distance. Now without changing my measurements, I'm going to take my compass and come up to the point above, and I'm going to draw an arc. So now what should happen is if I take my straight edge and I draw a line through my original point and my intersection, I should have parallel lines. Now mine's a little off because my point was really big, so I need to bring this line down. There we go, pretty close. Okay, so those lines are parallel. Well, our definition of an isosceles trapezoid says that the non-parallel sides, which are called the legs, are congruent. It's kind of like an isosceles triangle where two sides of the triangle are congruent. An isosceles trapezoid has two sides that are congruent. So what I'm going to do with my circle, or with my compass, is I'm going to come up to this point, and I'm going to go ahead and measure the distance to this point over here, or to where they intersected. I'm trying to find the length of that. It's like I'm copying a segment. So I'm going to find the distance there. Then what I'm going to do with my pencil is I'm going to go ahead and I am going to put a point somewhere on my top parallel line. Okay, so I just put a point there for my reference. And I am going to, nope, that's good. Okay, so now take your compass and drag it over to that point you just drew. And we are going to go ahead and take your circle drawer, and you're going to go all the way around so it looks something like this. It's going to create a really big arc. Now it should intersect that bottom line 2 times. If it doesn't, then take your straight edge and extend that line out. Well, if I were to draw a line from my point up top, my red dot here, to this one, I have not formed a trapezoid, but I've actually formed a parallelogram. Those sides would be parallel. And that's not what I want. So we're not going to connect it to that one. We are going to go ahead and draw a segment from that red dot to the one right over here. So now I've constructed this isosceles trapezoid because this length right here is the same as this length right there. So there is my isosceles trapezoid. Now let's look at some of the properties of an isosceles trapezoid. We know the legs are congruent. Go ahead and take out your protractor. So your protractor is what we measure angles with. And let's go ahead and measure these base angles. I'm going to take my protractor and I'm going to put it right here. And it looks like that angle is about 44 degrees. So I'm going to go ahead and label that as 44 degrees. And then I'm going to come over here and I'm going to measure this other base angle. Oops. And this base angle also looks like it's about 44 degrees. So right now it looks like the base angles are congruent. Well, I'm going to do the same for the other base angles. Just because they're not on the bottom, I still have these angles right here. And it looks like this, it's going to be obtuse, so it's bigger than 90. It looks like it's about 136 degrees. And I'll do the same over here. And that also looks like it's about 136 degrees for mine. Now remember, yours might not be the same measures as what I have. But what we should notice is that the base angles of an isosceles trapezoid are congruent. Okay, so we have that. We have the base angles are congruent. We have that these sides are congruent. Let's take a look at the diagonals. What I would like you to do with your compass is I would like you to come to our point up here. And I want you to measure the distance to the angle diagonal from it, so to the 44. So you're going to need to extend it out. Hopefully yours will go all the way. If it doesn't, then you can go ahead and take out your straight edge. Go ahead and come over to the other side. And without changing the measurements, you should see that they are congruent. Now mine's a little short, but yours should reach from vertex to vertex, or creating those diagonals. So this diagonal right here should be the same as that diagonal right there. So those are our properties of an isosceles trapezoid. Let's go ahead and summarize it. So for an isosceles trapezoid, we know the legs are congruent. We know that the base angles are congruent. And we also know that the diagonals are congruent. So there are our properties of isosceles trapezoid. Now it's your chance to go ahead and explore some more as you continue through the session. Good luck!